What? Where are we?
Hi guys, this is Athena.
This is Alex.
And do our data science final project.
From Bikini Bottom.
Yep. And the topic of our project is author authentication. So let's get into it. The inspiration of this project came from a set of thinking as maybe writing could be also some sort of biometrics for identifying whether it is the person that we're thinking of. And we thought that was interesting. That's why we decided to do it. And the problems already existing in this world include I know, includes a stolen work and similar work. So if two people claims that they both wrote it, so whose it is, I think by maybe examining things that they've written before, there could be some kind of biometric that could tell whether this work belongs to one person or the other. And furthermore, currently the website that we check for plagiarism on, Turnitin, only uses similarities and in continuity of the word. Say if you copy paste it from someone, but it doesn't check for style at all. So in a way, it's really bad at targeting plagiarism, as one person could write two pieces of things and submit it as another's work. So some previous work done on this, some previous work done on the NLP author identification range. There's OpenAI, which is a crazy bot that does a variety of things. It can be a customer bot, and it could also be sarcastic, and there's a whole range of things. If you're interested, you can check it out, that it can do. So if you it could also create summaries and just like basically write your essay for you, which is kind of insane. And it could also code for you. Yeah, so then some background research. This Stanford paper that used deep learning, trained two data sets, one C50 and then another one Gutenberg project, with 60 and 89% accuracy. And then when they used the CMS network, they actually got 99.8 accuracy on both. And another paper on author identification based on NLP using articles, the scientific journals, basically with 100 articles, 20 authors, they got 70% accuracy using neural networks, and then 500 articles, 10 authors with 94% accuracy, which is pretty incredible. And another thing that someone wrote, it's like one person could have like multiple Reddit accounts, and by looking at those texts and comparing them, they could kind of identify whether these texts were written by the same person. It's like another fun project that we saw. Yeah, so then some exploratory data analysis.
We got a whole bunch of ebooks. We picked these 9 new and old authors, male and all these other for a good starting place for to be able to pick out what writing. On the right side, you can see a list of our features. So just briefly, each row of data contains 10 paragraphs from each writer, condensed to one big string. The next feature was the narrative perspective, so we written third person, and then we looked at the average number of words per sentence, pretty self-explanatory, the average length, pretty self-explanatory. Then we created tokens and filtered those tokens. So taking that long string, we broke that string to where we tokenized it, meaning we took the string and turned it into a list where every instance in the list is one word. So yeah, and then we filtered it by taking the stop words, so words are, and it's really common words. Then we looked at the polarity and sensitivity of the writing, and then we created a bag of words idea. Bag of words is basically 500 of the most common words used for all their authors, and then the values are was that was used in writing or and CFIDF was basically how important were these words that they were used, how important in literature. All right. So here we're going to take a look at the training investment. This is a photo depicting how many rows per author there were. So Jane Austen had the most. So she had 37.
Yeah, it's because we picked a couple books from each author, and their books vary in.
Yeah, we tried to get. But we didn't unbound.
Yeah, and then we trained it based on each row is 30 paragraphs of like the backslash in. Yeah, and some specifics. So yeah, as Alex mentioned, we don't have any second person view books, which makes sense. And the average words per sentence and average word length, we're gonna go over it later and show you a graph about it. And then polarity, subjectivity, polarity went from -1 to 1, and subjectivity went from a 0 to 1. So it's all kind of subjective in some way. And the filter tokens we got from dividing the tokens that were unique over the tokens that were just like just generic. Yeah, over everything, basically all the tokens that we had. Yeah, and sorry, statistics.
Yeah.
Yeah, and you can see that although the average sentence length didn't vary that much, the average word length actually varied more than the average sentence. So Mark Twain is actually really good at using really long words, which is helpful. Yeah.
Yeah. Every
And the TF-IDF basically is used to finding the relevance on a string of the representation. And we found how important they were in constructing the paragraph compared to, with the 500 most common words. And here is a distribution plot where the red line signifies the normal distribution, and then like the blue dots is our data, which means that it's skewed towards the right when plotted on the normal curve. So, but it's still a bell shaped of some sort, just a little bit heavier on the right. So our approaches and methodology.
These forms and split the data. Formology is here. Random forest and ADA boost, we both use ensemble size for those, and then the progression using the MPL.
And our results and interpretation. So for random forest, we got the precision and recall and F1 score support for everything basically, and this is going to exist in all of our further models that we trained. Basically, the best performing ones were Shakespeare, with a precision at 47% and a recall at 52%, and Edgar Allan Poe with a precision at 48% and a recall at 34%. And the worst performing one would be Agatha Christie with a precision at 28 and a recall at 20. And I just wanted to point out to Oscar Wilde too, with a precision of 0.41, but a recall of 0.08, which is really little, which means that it's kind of identifying everything as wild. And our accuracy is actually not bad, 0.37, although not as good as we'd hope. But yeah. And the next one is logistic regression. So logistic regression actually was really, really bad at identifying wild, having 0 all across the board with a precision of 0 and recall of 0. But looking at some of the things that he did better than the random forest, Mark Twain, precision 57, recall 15%, and Hemingway, precision at 46% and recall at 40%. Edgar Allan Poe, precision at 45% and recall at 26%. And Jane Austen, precision at 42% and recall at 57%. These are really good, except it's really, really bad at training wild. Yeah.
All right. General takeaways. The best performing people with Ada Boost were Mark Twain, with 2% recall, and then Oscar Wilde, 2%, but the recall is pretty low with 0.09%.
So wild is just really bad across the board.
And the last takeaway accuracy only the best.
That's pretty good.
Pretty
Yeah.
high.
Yeah.
The only issue was
Okay, so conclusion. The information gain we got from random forest actually showed that actually average word length and average word percent and subjectivity polarity, these are all the things that we initially constructed for ourselves. So the fact that these had the most information gain meant that it did kind of better than the bag of words system and the TF-IDF that we came up with. So we were actually surprised that these things matter. We assumed that it would matter, but the result proved us right. And the overall conclusion.
Yeah. Random. All the variables. The worst was actually kind of surprised. It was neural networks. It miscounted a lot of data.
I think it could have also had something to do with how we wired it, because we don't have enough knowledge about like all of the activation functions. We didn't know how to go in and tweak everything to our likings, and we didn't. And our data set was 1,000 rows across and 1,000 columns across and 100,000, 150,000 rows down. So it was kind of impossible for us to run any neural network at a good pace, and we couldn't do CNN because these things were not related in any ways. So yeah. But this is the end of our presentation. Thank you for listening, and see you guys next time.
Yeah,
probably not at Bikini Bottom.
Yeah.
Yep. Bye.
Thank you. All right.